Hi, everybody. Today we're going to look at the statistics section, KK in Algebra 1, and we're going to find an equation of a regression line. Now, the last time I tried this, the IXL didn't accept an answer because I didn't put 0 point something, and it also didn't round correctly because mine was a little more accurate than they were expecting. But hopefully everything will work out. You're going to have to use some type of graphing calculator or graphing utility. Now, if you're using a TI-83, it is going to give you a regression line and a coefficient of correlation coefficient and so on. But hopefully you'll be able to use another, open up another window. I'm just going to go to another tab. Move this, if I can move this out of my way. There we go. Got to move myself out of the way. I'm going to go to a new tab, and when I do this section, they're going to give me data. Come on, I'm getting a lot of lag today. There's my data. So I'm going to get some data, and what I'm supposed to do with this data is I'm supposed to analyze it and get a least squares regression line. So here's my data right here. And this is the grape juice in France. And the grape production doesn't seem to have a whole lot to do with the grape juice sold. It looks like as the grape production goes up that, yeah, there's a certain small increase in grape juice sold, but it's not a big increase. And I would say that there's not a big correlation between this, that the positive correlation isn't very strong. But here's what we're going to do. I'm going to go ahead and open another window, another tab, and I'm going to go to what's called Desmos, Desmos. You can type it in the address bar. You can type it in a search bar. I'll show you it works. And it's going to be this Desmos calculator. I think you're going to like it the best. It's very easy to use. It's very intuitive. And it gives you a graph over here. It gives you some boxes. Now, in order to put this table in, there's a couple of ways to do it. One way would be to copy this onto your paper and then to transfer it into a table over here. And you can get a table and you can type in your values. In case they aren't listed where you can copy them, you have to copy them yourself. And I'm going to write them down. And 5.8 and 5.9. Hopefully I'll actually get them correct. And I go to here, I go to my table. It's usually easiest to type in the X's first, 3.3, 4.6, 4.7, 5.4, 5.9, 5.6, 5.9, 5.4, 5.8, and 5.9. Now, if you have one little error in here, by the way, here's our points. And as I said, they don't have a very strong correlation. I'm going to go ahead and zoom this into the center for you so you can see it a little bit better. It doesn't make any sense to talk about any of these negative values over here because these are positive, real things. Now, this is the grape production in, let's see, it's probably millions of metric tons, and the grape juice, billions of liters. Man, that's a lot of liters. Anyway, this is the metric tons, and down here, and these are billions of liters over here. I would be surprised. It should have been millions of liters, but anyway, there you have it. I'm going to guess that my least squares regression line is going to go through right about here. It's not going to have a very steep slope, and it's not going to have a really strong correlation. But the way you do it is you add an expression, and the expression we're interested in is y1 tilde. The tilde is next to your number 1 up in the upper left-hand corner of your keyboard. You can also use their keyboard if you want, and it's located right here in the ABCs. So if you want to use their keyboard, you can. It's mx1 plus b. Now here's our least squares regression line, this black line right here. There's our slope, 0.109. Notice I have to round it to the nearest thousandth. That's what they ask for down here. They want you to round this to the nearest thousandth to get your least squares regression line. And 5.199. Hopefully, last time I rounded this, they didn't like that I rounded it up because I think theirs just gives them to the thousandth. So they may not get the right answer. Hopefully I'll check it and it'll work out. 5.199. So I'm gonna round it 0.109. You do have to put the 0. The last time I didn't put the, oops, if I put a 0. The last time I didn't put the 0 and it didn't count it right. And 5.199. Hopefully it works. Yeah, it did. Okay, now for the easy way. The easy way is you copy it and paste. Now I'm using Command C since I'm using a Mac. You may want to use, you may be using Control C instead. What doesn't seem to work is it doesn't seem to work to do this and use this copy. That doesn't seem to work for this. So I'm using Command C. And when I get to it, oh, by the way, I got to get rid of these. Hang on, let me get rid of these for you. Come on. There they are. Get rid of it, get rid of it. There we go. Now, don't add a table. That's where a lot of people go wrong. You just go to a blank square and you hit, for me, Command V. And it puts in my, my data. Now, this was about supposedly Neil Diamond, I'm guessing, is a singer who appears to an older demographic. And supposedly based on the age, they know more of Neil Diamond songs, or Rod Diamond in this case. It looks like the 61-year-olds know lots of them, the 50-year-old not so much. So clearly it was more as 60 years ago. Now there does seem to be a correlation. As the people get older, they seem to know more of the songs, except this. This 3510 is the outlier. This is the guy or the girl who's maybe really old-fashioned or has a parent who's really into Rod Diamond and knows more of the songs. But if we got rid of this outlier, you can see that it's a very strong positive correlation. With this in place, it's probably not going to be that strong. So anyway, I copied it. I use Control C. You highlight them first. Let me highlight them again. And I use, for me, Command C. And I go into here and I used, again, Command V. Now there's my points. And I'm gonna, there's one of my outliers down here. But here's my really big outlier, isn't it? See that? See, because they look like they're lined up over here, don't they? See that? In other words, if I were to interpret this, I would say that pretty much anybody under the age of 40 probably doesn't know any based on this, on these data, if I hadn't seen this one person over here. Now what's going to happen is it's going to go more like this. The line is going to go more on that line. So we're going to type it in. Y1 tilde mx1 plus b. And there's our line, our least squares regression line. What does this 0.347 mean? Well, the slope is telling you that for each year of age, we expect that somebody's going to know maybe a third more songs. So for every 3 years they age, we expect, or that they're older, we expect that they know more songs. Now, somebody who is just being born knows -7 songs, which doesn't make any sense. But for our graph, this 0-20 would be anybody age 20 or less isn't going to know any. That's what this basically means. I think that it's important to interpret what's going on, but for the IXL, I know you guys just want to get it done. 0.347. We have to round the 6 up because there's a 6 next to it. 0.347. And I'm in the way again. Move myself out of the way one more time. And now my B value, negative 7.085. Negative 7.085. Real life getting in the way of my math. This really doesn't have any real interpretation to it. Now this time, we have a new spinning top among different age groups. Recorded the age of each child and how long he or she got the top to spin. So the age seems to, at first, increase, and then it seems to have decrease. This doesn't seem to have a very strong relationship at all. There's this first pair seemed to be very strongly positively correlated, but then it seems to be almost random. So I'm guessing that there's not going to be a very strong correlation. But remember, we just copying them, and I'm using Command C. I go to my Desmos. I click these out. I go to a blank square, not a table, and I put it in. Now there's my data. It looks like it's negatively correlated, actually, except for this super outlier down here. The six-year-old was the super outlier, wasn't he? Because he couldn't figure it out. That was the problem. He probably had trouble spinning it. But these are negatively correlated. As you get older, you can't seem to spin your top. So let's see what the negative correlation is. Y1 tilde mx1 plus b. What? Oh, because of this one. See, if this one weren't here, it would have been a negative correlation. As it is, it's not a very strong positive one. Not a very strong positive correlation. But it does appear to be positive because of this one. If it weren't for this point, if I took this point out, you would see that this would be a negative correlation and it would be very strong. That's one of the reasons why a lot of times they take outliers out. Anyway, for this particular problem, we're supposed to put it in the way it's written, 6.268. For every year of age, we expect that the top is going to spin an extra 6 minutes. That's what that would be an indicator of, which is why this pair seems to be the big indicators. And the negative 8.304. Which doesn't really have a real meaning in terms of what's happening there. In other words, a baby would get it to spin negative 8 minutes. No, it doesn't make any sense. All right, this one. Again, I'm just going to hours slept, minutes needed to finish math homework. Maybe there's a correlation, maybe not. Let's take a look. We copy them, put them into our Desmos, get rid of these guys, go to a blank square and fill it in, and it is negatively correlated, as we did not expect. The more sleep, the longer it takes. See, maybe he's drowsy or something. This does definitely look like a negative correlation with no major outliers. So let's take a look. Y1. Remember to put the 1. It's not a subscript, it's just Y1. In fact, I'm going to type it on the keyboard so you can see it. I get myself out of the way. Come on. There we go. Get out of the way. There we are. Okay. Here's my keyboard. I'm going to go to the ABC keyboard, and I'm going to type Y, and I'm literally typing just the 1. Oops. Sorry, guys. There it is. Y1. Now I need my tilde, which is in the ABCs. It's right here. Yours is located up in the corner of your keyboard, right up in there. Anyway, tilde, MX, MX, and just a plain old 1. You don't put a subscript or anything. Don't forget the plus B. It's a real hassle putting it in with the keyboard down here, so I'm going to get rid of that. There it is. You can see it's really having trouble with this. There we go. Okay, we can see that it's negatively correlated. What does it mean? So basically for every extra, let's see, hour of sleep, these are hours of sleep, he needs more minutes to finish his math homework. So the more hours of sleep he gets, the more hours of sleep he gets, the less minutes he needs to do his homework, which is that it's going down 6 minutes for every hour of sleep he gets. So that's the interpretation. It's negatively correlated. The more sleep he gets, the less time he needs for the math. 128 would be, assuming he stays up all night, he would expect to spend a little over 2 hours on his homework. If he gets a really good night's sleep, he expects to spend about an hour. That makes a lot of sense if you really think about it. Anyway, sorry, I know you didn't want the interpretation. You just want to know, how do you put the numbers in? Negative 6.395. If it's rounded, and the plus 128.192. 128.192. I'm just going to double check it. Yep. And yep, looks like it's good. And there we have it. Dang it, I'm always in the way. There we are. How far are we? Not very far. Okay, walking speed and amount of water. How wet a person will get in the rain. In other words, is it better to walk fast or walk slow or run like hell? So here's the walking speed going really slow versus quite a bit faster, and the amount of water does seem to be going down. So it looks like you want to run a little bit. So walking speed does affect it maybe. So let's take a look. We're gonna copy these guys. Dang it, come on. Come on, having issues. There we go. Command C. Go to Desmos, close these guys out, and we put it in the blank box. There's my data. Definitely a strong negative correlation. These two outliers, they're not going to affect it a lot. They're still going to, our line is going to be like right here. And it definitely looks like if we could go, is this miles per hour? Meters per second. If we could go fast enough, say 1.2, 1.3 meters per second, it looks like maybe we would avoid rain altogether. That's not the case, but oh well. Y1 tilde mx1 plus b. There we go. Now, here's our y-intercept, which means if we could manage 1.4 meters per second, we would not get wet at all. Assuming the rain starts at a given time, that would probably be true. Anyway, the negative 1.9 means basically that for each meter per second we increase our speed, we expect to be that much less liters of water, maybe, amount of water in kilograms. Wow, a kilo of water is a liter of water. It's almost, in fact, it is exactly 1 liter is 1 kilogram. So this is liters of water, if you like, because they're looking at the difference in her weight in kilograms. I'm assuming that the rain is the only thing increasing her weight, assuming she's not chowing down on a sandwich or something on the way. So there it is, negative 1.904, negative 1.904, and the x value is the 2.74. Now, what this represents is if she sits in one place and doesn't move for the time period of the rainstorm or whatever, we will expect her to get almost 3 liters of water saturating her clothing. So 2.741. There we go. Hopefully I got him in there correctly. All right. Approval rating. Final approval rating immediately leaving office for each mayor based on initial approval rating. Oh, so he did a study before and after for mayors. Now let's see. The approval rating is definitely going up over here, and it seems to be going up over here. There does seem to be a relationship. The initial approval rating has some effect on the final approval rating. So there it is. We're copying. That's Command C. And we go into Desmos. Close them out. Blank screen. Command V. There's my data. Definitely a strong positive correlation. The correlation coefficient is that that value that we're going to see here in just a second. Hang on, I'll put it in there for you. Y1 tilde mx1 plus b. And this R value is our correlation coefficient, and it's 0.956. Very, very strong positive correlation. 1 is the strongest correlation you can have. If it were going down, we would be looking at negative 0.9559. But it's going up, so it's kind of, you can think of it like a 95% correlation. The 1.65, these really don't have a lot of meaning because this is just a relationship between two, like in the initial approval rating and the final approval rating. The M and the B really don't have a good interpretation. We'll put it in 1.655. And it's a negative value. Negative 55.109. Sometimes this messes me up. Negative 55.109. The last time I rounded up on one like this, it counted it wrong. Negative 55.109. Let's see if it works. It may count it wrong. It might think it's 8. Let's find out. Oh, I'm in the way again. Yeah, okay, it was all right. Okay, let's see. Average movie duration, percentage of customers that bought snacks. Aha. So as it goes up, it definitely looks like there is a relationship, and only 9 minutes of difference seems to have a big difference in the number of snacks bought. Clearly, what does the movie theater need to do? If you think about this for a second, very, very clearly, they need to put in some more previews, don't they? And in fact, I would put in, if it were me, I'd put in 10 minutes of previews just to see if I could stretch it just even a little more. An extra 10 minutes of previews, not just 10. Definitely for a 90-minute movie. So there definitely appears to be a correlation between them. I hope you guys don't mind. I'm taking time on the interpretations on these. There we go. Copy, Command C, go to Desmos. And I know you guys want to do your own, but this is so much fun. Okay, put it in. Remember, it's Command V for me, probably Control V for you. There is a relationship. It is positive. It's definitely positive, and it's going up pretty rapidly. Let's interpret it in a minute here. We have a Y1 tilde M X1 plus B. Don't forget the plus B. The negative 229 doesn't have any real interpretation in life. But this 3 is very important. This slope of basically 2.717 is almost exactly 3. For each minute that the movie goes up in time, we expect to sell 3 more snacks. So put in lots and lots of previews, which seems to be the case, doesn't it? So let's go back and put it in. 2.717. This kind of information is the information that data analysts actually give businesses. Negative 229.007. Negative 29.007. No, 0.077. Come on, go back. Go back. There. 229. 229.077. I'm going to double check it. I'm getting lag. Yes, that's right. And 2.717. Yeah, it looks good. Come on. There's my lag. Okay. Bike ride to work takes longer some days than others. Temperature. The low temperature seems to take longer. Interesting. Higher temperature seems to be shorter. So there seems to be a negative correlation. As the temperature goes up, the bike ride commute goes down, which seems odd to me. If it were colder, I would be riding faster, I think. But it definitely could have something to do with the fact that there may be snow on the ground and so on. Anyway, here it is. Let's copy them. Put them in our calculator. I'm really getting a lot of lag today. Here we go. Oh, come on, really? Let me get rid of this. Oh man, I got a bunch of stuff going on. Maybe I made a mistake when I was copying. Oh, maybe it's because of the negatives. Yeah, it's the way they put them in. See those negatives right there are giving me issues. I could probably copy these. Let's see. I can Command C. And then I'll have to type in the other two. Yep. And then I'll have to type in negative 260. And the negative 143. I can't imagine anybody's still with me on this, but there we have it. It is possible to have negative temperatures, and there definitely appears to be a very strong negative correlation depending on the temperature. I'm just going to leave it like it is. I'm going to type in my y1 tilde mx1 plus b, and there's our equation. This b value is what we expect at 0 degrees temperature, isn't it? At 0 degrees, we expect her commute to last 47 minutes. As the temperature increases, we expect that the commute to go down 2.2 minutes for every degree of temperature. Now let's see what her ultimate speed could be. If the temperature is 21 or a little over 20 degrees, we expect that her commute to go down to 0, which of course it isn't going to do that. So this point isn't going to work. What we talk about, and that's one of the reasons why we talk about a reasonable domain for a mathematical model. The reasonable domain would probably be from, say, negative 10 up to 10. Or in this case, because my data really only goes from -1 up to 9, that's kind of my domain for this data set. So I probably shouldn't use the mathematical model outside the domain. Anyway, negative 2.233 and 46.839. Yes, and 46.839 looks good. And we have an article, members and years. Man, we are going super slow. I need to get done, so I'm just going to copy it. And oops, I want to look it up. I want to Command C. And we're going to get rid of these guys. I'm going to put it in blank. V. It worked out. Looks like a very strong, fairly strong negative correlation. This isn't very strong. This is probably about a negative 0.8, if I had to guess. So let's see, y1 tilde mx1 plus b, negative 0.75. So it wasn't too far off. There it is. There's our negative linear regression line. Negative 3.269. And the x value, 31.53. Oh, this is where this silly thing may not round it right. I hope it doesn't count it wrong. 31.539. The last time I did this, it put 8 and it counted this one wrong. So hopefully it doesn't. Yep, it put the 8. The problem is this is rounded, and if you go further, it probably would be 4, 8 or something, which means that the 8 doesn't really round. So my rounding isn't working out. I'm gonna have to be a little bit more careful with this one. If it's a 5, I think I'm just gonna go ahead and go with this lower one. Darn it. Anyway, I'm pretty sure you guys got it by this time. Maybe I should do one more interpretation and then let it go. But you know me, I don't like to give it up unless I'm gonna absolutely have to. So let's do another one. I'll do at least one more. Let's see. Haley notices that everyone in her class reads at very different speeds. She wonders if a reading speed is related to the number of books he or she reads. Books read last month and seconds needed to read the paragraph. So this is the time needed to read and the number of books. So as the number of books go up, the time seems to be going down. This seems to be a pretty strong negative correlation, except for this weird outlier right here. This one seems to be the outlier, and you'll see it on our data set when we put it in. So let's put in our points and see them. I'm going to get rid of these. And I think I'm going to go ahead and interpret this one for you as well. So let's put it in. There's our data. And like I said, here's our outlier right here. You see our line would be really nice and correlated very strongly right here. How come I don't have all the points? Where's the others? Right. I should have some more points. Where did they go? I've got, oh, 955. Same point. Duh. That's why I only have 4 points, because 2 of them are the same. Now, that is going to have an effect, though. This point is going to the 955, which is right here. This is a double point right there. So this point is going to have more effect than these other 3 points. In other words, it's probably going to go a little closer to this point and not so much through these 2. So it's probably going to get a little closer. You'll see when we do it. Y1 tilde and x1 plus b, there it is. You see how it got closer over here and further away over there? The reason is because there's a double point there. Negative 5.11, basically we expect that the time that it takes to read the paragraph will go down 5 seconds, for each book that somebody read before. If somebody read no books at all, we would expect that it would take them 94 seconds to read the paragraph. So let's take a look at the equation again. Negative 5 point what? 0.113. Negative 5.113. This is the number of seconds we expect, the seconds needed for the paragraph for each book they read. 94.103. There it is. It's almost time to go. That's my bell. So I'm going to let it go at this point. I will definitely go in and do it to 100 one of these days. For now, I'm going to let it go, and I hope you guys will try yours. You copy them and paste them. Copy them, paste them in to a blank box. Don't paste them into a table. And type in your regression mx1 plus b, and be very careful and copy it over to your equation, and you're all set. So hope you guys got it, and I will see you back again. Bye, everybody.